In this video, we're going to take a look at the changes to the missile model inside Command PE. First of all, in the existing model of missiles, basically each one had a specific range band that would move up to that speed and maintain that speed until it reached its run-out distance. If we, for example, were to take a quick little look at the particular weapon that we're looking at now, you'll notice towards the bottom, it has the different type of propulsion as well as what it achieves. In this case, this particular engine is a rocket booster sustainer. This particular type will allow it to cruise up to a certain speed, run out of fuel, and then slowly slow down as it approaches its target. In this case, if our target happens to be in these different range bands, this will be the ultimate terminal velocity before the weapon starts cruising its way towards the target. Keep in mind, different types of missiles have different types of methods of actually navigating themselves once they get in the air, and those can be represented as different types of special properties of this particular weapon. So let's go ahead and see what happens here. So we'll give this radar battery a couple moments, and we've acquired a target. We'll then launch a pair of different missiles here. In this case, we'll launch one of these, and we'll launch one of these. Now, once the missile leaves the battery, we'll go ahead and follow its performance through the air so that you can see exactly what we mean. So in this case, we've grabbed this missile, and we can see that its airspeed currently is running at about 472 knots. It accelerates quickly up to its terminal speed here. And then once it achieves its terminal speed, it begins to slowly slow down as it starts to approach the target. Now, this particular target has chosen to begin maneuvering. Because of that, this missile is now having to turn itself in bleeding speed. Now, keep in mind, the motor is no longer firing, so now it has to try to reacquire it and make its way back up to actually complete the engagement. Now, as it's completing this high G turn, it has lost a significant amount of energy and is actually beginning to slow down. The target that it was attempting to intercept actually tried to turn around and run from this particular scenario. Now, this effect can be made even more obvious by taking a longer range shot. In this case, we'll go ahead and engage this target, which is right on the edge of our maximum range. So what will happen now is the weapon will launch, just like it did before. It'll climb up to a very, very high ballistic trajectory, and then it will start dropping down onto the target itself. Keep in mind, as it's starting to drop, since that motor is no longer running, it's losing a significant amount of speed. Unfortunately for the target, it has not yet spotted this weapon that is currently traveling on a ballistic trajectory. Let's go ahead and flip to the 3D view very quickly so we can go ahead and take a look at exactly what this looks like from the side. Now, the weapon is dropping down, it's not doing anything special, and our target, of course, will probably spot that missile at its last possible moment, making it extremely dangerous. Had this been a daytime engagement, the entire process might have been a little bit more aggressive, but in this particular case, there was absolutely no warning for this weapon to arrive. As you can see, the target has begun maneuvering. Its initial turn is going to be to turn away from the missile and then try to outrun the missile, which is traveling significantly slower than it was originally. So unfortunately for us, the missile had more than enough time to get to the target, and a successful engagement was completed. In this variation of the scenario, we have a slightly older aircraft attacking a slightly older craft that's been equipped with a missile warning system. So we're going to go ahead and order up a dual attack. And then as soon as the weapons are launched, we'll go ahead and monitor things from the other side. In this case, our MiG-29 is well aware of the fact that there's another aircraft out there and actually has the ability to go ahead and target if it weren't for the fact that it doesn't quite have weapons that are a little bit closer to it. So if we switch to God's eye view, we can see that the F-16 has just fired its first missile and it's heading directly towards the MiG-29. Now, this MiG-29 has been specially modified with a missile warning system so that it has the ability to identify when incoming missiles are going to improve its reaction time. So we'll speed up time a little bit. Watching God's eye view. And now the missiles are noticed immediately. We'll go ahead and take a look at the missile itself. We'll notice that it was actually picked up by the radar system on board this aircraft. Now notice this aircraft, rather than attempting to beam the missile, is simply turning around and bringing up as much speed as possible as the missile moves towards its terminal velocity. In this case, had the MiG-29 had a little bit more warning, it might have been actually had the ability to go ahead and get out of the way. Also notice this MiG-29 is attempting to beam our friend the F-16 because it knows that the particular radar guidance system in the F-16 is vulnerable to Doppler beam notching. So now that the missile has brought its way past the target and come back around, the F-16 is now going to go ahead and try to take another shot. Two more missiles on the way. Our MiG-29 catches it earlier and again attempts to beam the F-16. Now notice in this case, because the missiles were a lot closer fired, MiG-29 is simply turning tail and attempting to outrun the missile to force the missile to actually run out of energy. In this case, we'll watch from God's eye view as the missile attempts to catch up. Current missile is doing about 1,700 knots. Our current MiG-29 has spun all the way up to 830 knots. Realizing the MiG-29 cannot possibly outrun that missile, it is now attempting a very, very aggressive high-G maneuver at the last possible second to try to beam the missile and maybe deny it, but unfortunately, the missile connects and is effective. As you can see, this is a much more realistic model for missiles, and it simulates real-world tactics in a greater extent.